Question number 22nd. An open tank with a square base and vertical sides is to be constructed from a metal sheet so as to hold a given quantity of water. Show that the cost of material will be least when depth of the tank is half of its width. If the cost is to be least when depth of the tank is half of its width, if the cost is to be borne by nearby settled lower income families for whom water will be provided, what kind of value is hidden in the question? Answer. Let the length, width, height of the open tank be x, x and y units respectively. Then its volume is x square y and the total surface area is x square plus 4xy. It is given that the tank can hold a given quantity of water. This means that its volume is constant. Let it be V. Then V is equal to x square plus y. The cost of the material will be least if the total surface area is least. Let S denote the total surface area. Then the surface area would be equal to x square plus 4xy. We have to minimize S object to the condition that the volume V is constant. Now S is equal to x square plus 4x. Now putting the value of y into this equation, it makes it S is equal to x square plus 4v upon x. Differentiating S with respect to x, we'll get ds upon dx is equal to 2x minus 4v upon x square. Now again differentiating ds upon dx with respect to x, we'll get the double derivative of ds upon dx is equal to 2 plus 8v upon x cube. The critical numbers of s are given by ds upon dx, that is equal to 0. Now since ds upon dx is equal to 0, putting the values into the equation, we'll get the value of x, that is x is equal to 2y. Clearly, the double derivative of ds upon dx is equal to 2 plus 8v upon x cube, that is greater than 0 for all the values of x. Hence, s is minimum when x is equal to 2y, that is the depth of the tank is half of its width. Here, base is directly proportional to the height.